Two things left in this course. The first thing is web security that we will be starting to cover today and hopefully complete next week. And then second thing, which is more to be aware of common attack scenarios. Common attack scenarios on web applications. And this is commonly known as OWASP. OWASP Top 10. I will explain this maybe the last session. When you hear this term web security or security, what comes to mind? What are the practical aspects of security that we need to take care of as developers? Okay, so basically there are 4 aspects that we need to take care of as web developers. The first thing is authentication. So what does authentication mean? Verify that the user is who they claim to be. Establishing, basically the goal is to establish their identity, to establish whether they are a genuine user, and if they are so, what is their evidence? What's their burhan? How they can prove this to us? Usually password, but there are, of course, many other mechanisms. We will focus on the most common mechanism, which is password-based authentication. But of course, there are many other mechanisms, such as biometric and many others. But at the end of the day, all these mechanisms, their goal is to establish the identity of the user and verify who they claim to be. Okay? So once we know the user, we know who they are, and maybe we also know what is their role. Typically, we will know the role through authentication. We know who the user is and their role. For example, when you log into Banner, Banner knows whether you are an instructor or student or admin. Through the authentication, we can also establish 2 things: who the user is and what's their role. And based on these 2 pieces of information, particularly the role, comes to the next step of security, which is authorization. So it follows authentication, is followed by authorization. So what is authorization? User typically has one or many roles, and roles gives you privileges and give you permissions within a particular app. So when you log in, we know who you are, and then the system should only offer you what you're supposed to access. Not only this, if you are curious and you try to access other parts of the app should deny access. So verifying that and only allowing the user to access what they are supposed to access, what they are allowed and entitled to access, that is basically authorization. So we have authentication and the second aspect of authorization. What's the third aspect of security? Practical aspect. Us as web developers, we need to be familiar with. Confidentiality. What does this mean? Protecting sensitive data that our application manages. Sensitive data could be, for example, credit card information, could be passwords, could be health records. Anything sensitive and valuable, in a worst case, when an attacker successfully managed to hack into our application and they can even get our files or even get access to our database, they cannot get the information because you have put the efforts in encrypting that sensitive information that even if somebody managed to get into the data, they cannot read it. They can get it, but it will not make no sense to them. So confidentiality is all about making sure only authorized users can read particular pieces of information that our application manages. And the typical example is the credit card information. So that's why in the news we always hear hackers, they tap into databases, they stole credit card details, they stole passwords and so on. Most likely because those passwords and those credit card information were stored in plain text in some database. So once the hacker managed to tap in to this database, they can download the whole information. It's plain text. But if it was encrypted and the secret key of encrypting it is kept secure, then even if they get access to the information, it will not be able, it will be encrypted. They will not be able to make any sense of it or make any use of it. So that's what confidentiality means. Last one is, in terms of practical aspect of security, is integrity. What does this mean? In the context of security, integrity means if I send you a message, for example, I am 100% confident that that message was not changed along the path getting to you. For example, if QU is sending a message to QNB, transfer 1,000 riyal from QNB account to Ahmed's account. We don't want somebody intercepting that message and adding a couple of zeros to the amount. And then the bank, instead of transferring 1,000, it will transfer 1 million. We don't want that to happen. Yeah, we want to make sure the message arrives and the recipient is confident, 100% confident, the message was not checked. As a web developer, you need to be familiar with mechanisms to do authentication, mechanisms to do authorization, mechanisms for confidentiality and integrity. Also, you need to be familiar with common attacks that attackers do against web applications, and you need to be familiar with how you can avoid such attacks. This OAuth, and this is a non-commercial a non-profit organization. Every 3-4 years, they issue a document explaining the top 10 attacks that are commonly observed against web applications. And us as web developers, we need to be familiar with them. The minimum, because security is a huge area, a huge topic, but I'm just trying to make it more concrete and more practical. So 5 things, basically, you can summarize security, at least as a beginner. Authentication, authorization, confidentiality, integrity, and be familiar and be aware of common attack scenarios. Start with authentication. Let's get started with authentication. Now, for authentication, as I explained, there are 2 ways to do it. Roll up your sleeves, do it yourself. Build it yourself. That's one way of doing it. The second way of doing it is delegate. It's called delegated authentication. You push it to Google or Facebook or Twitter or GitHub or Microsoft to do the authentication for you. You don't manage users and their passwords, and the headache of allowing them to reset their password, or the headache of protecting passwords and so on. You push all this responsibility to an identity provider. Okay, so let's first start and look into how authentication works if we decide to do it ourselves. Is a typical implementation of authentication. So you might have a web API, something like in this address, authentication login. Typically, it will be provided as a post, using a post verb, and in the body of the request, you send an object that has the username and password. This is the typical way of implementing it. Once I send this, and if the authentication is successful, what I'm supposed to get back? The account itself, the user object. What is the difference between 401 and 403? 401, unauthorized, should be returned in case of failed authentication. So if you try to authenticate, if you try to log into some system and you type in the wrong username and password, what you're supposed to get back? What's the status code you're supposed to get back? 401, unauthorized. Now, suppose you already logged in, but you are trying to access something you are not supposed to access. For example, you logged into Banner and you are curious to know the transcript of your friend. If you try to access the transcript of some student that is not you, student's ID is not your student's ID, what the system supposed to respond? What was supposed to be the status code to be returned to you? 403, forbidden. So please make sure you are familiar with the difference between the two. 401, unauthorized, when should we return this? In case of failed authentication. And 403, forbidden, in case of failed authorization, okay? So in here, if I type in some wrong password, I'm supposed to get 401, unauthorized. Authentication failed, username and or password invalid. And don't be too nice and say, oh, username is invalid or password is invalid. Don't do that. You are opening a gate, like giving more chances to attacks. So you just make it vague. Username and or password is invalid. Yeah. Okay. Now, if everything went okay, I'm supposed to get 200 okay. And I get the whole user object. Typical attributes is the roles. So the user might have one or many roles. And the reason why I'm returning the whole user object is, first of all, in a typical application, once you log in, the app will say, welcome, and your name. How would the application know your name? From the login. So instead of doing it in 2 trips, once you log in, you say, oh, login successful. Oh, by the way, who the user is, do another trip to the server to get this. You do it both in one step, 2 birds, 1 stone. Yeah, you authenticate, and then you get back a user object. This user object has some useful pieces of information that you might make use of in the app. And also, most likely, it has some role, and you can make use of this role to customize the user interface. Yeah, remember, for example, for your project, the role will be customer or manager. If customer, I only show them the jobs and only their job. They cannot access other people's job. If they are manager, I give them more privileges, and I show them more menu items. Mentioning this, don't be tricked. Don't put authorization only on the client side. Authorization, you should put it on the client side and on the server side. What does this mean? There's a common misconception in developers' mind. The user does not see the option in the user interface does not mean that that option is secure. The user can still get the URLs. Make visible the user privileges, what the user can do. Okay? But that is not sufficient. You still need on the server side, for example, in your project, if you have something like /calendar as a URL, you need to make sure only the users with manager privilege or manager role can access that URL. Authorization, you need to do it in both sides, on the client side and on the server side. Yeah. So don't rely on this security through obscurity, which means, what this means is if the user does not see the link to access that privilege or to access that functionality, it does not mean that functionality is secure. You still need to make sure the authorization is verified on the server side. I have here is the login. So what I do, I take the username from the body of the request and the password, and then I'll call this login in the user repository. So in this user repository, I'll go ahead and find the user that has that particular username. Hopefully, if I don't find it, I will be throwing an exception. Username and or password invalid, authentication failed. Now, if I find the user, I'll try to see if the password match. If they match, then lucky, we have a match, so the authentication succeeded. And I send the user object. But before I send it, I delete any sensitive information from the user object I'm getting from the database. So I first, this is a user object coming from the database. I go ahead and delete the password, then I'm returning the user. He has signed up, created the login, created an account, and they signed up. And we took the user object that they want to create, and we send it to this add user, repository method add user. So in this repository method, we go ahead and use this library, bcrypt library, and hash the password and salt it. So hashing, it takes some text of arbitrary length. So I have some text, some message. It could be very long, it could be very short. The length of it is n. So I'll pass it through a hashing algorithm, and then I'll create from it a fixed length string. And this string really represents kind of a fingerprint of that text. And by the way, if that original message changed with even one dot, the message digest or the hash will be completely different. There are many algorithms out there to do hashing in terms for security purposes. One of them happens to be called SHA-256. There is SHA-512, SHA-128, and so on. And the number there, what 256 means here? The length of the hash that will be produced. So you give it 1 gigabyte of text, what it will give you? 256 characters. You give it 100 characters, what it give you back? 256 characters. So that's what hashing is. You give it an arbitrary text, it goes ahead and kind of mash it and squeeze it until it becomes 256 characters. So take a look at this. So if I run this, this is basically the hash. This is the concept of hashing. I take a function, I give it an arbitrary text of n length, it gives me back a fixed length hash. Okay? And there are many algorithms to do this. One of them is SHA-256. Take a look at this. If I change this with one small little change, let's say I remove this one, for example, and I rerun this. Take a look. This starts with 6163. I run this again. Take a look at the hash. It's a completely different hash. This is the power of hashing. Like small change in the input gives you big change in the output. One of the properties of a good hash function. Yeah. Now this hash function is of course some smart algorithm behind it to produce this. And this is unique. For any different text, you get different hash. If we take this one, plus we take this hash, and then we encrypt this hash, then this becomes a mechanism to achieve integrity. Message, I send you a message. I want to make sure that message has not changed along the path. So one way to achieve this integrity is take the message, hash it, and take the hash and encrypt the hash. Then what I do, I will send you the message and I will send you with it an encrypted hash. At your side, you will do the same. You take the message, you hash it, and you encrypt it within the same key. If both encrypted hashes match, then the message did not change. In this area, there are so many algorithms. I'm just showing you just one example. What I'm using here, I'm using HMAC SHA-256. What this HMAC stands for, it's a hash-based message authentication code, and the hash is created using SHA-256. So what I do here, the sender and the recipient will agree on a shared key, on a secret key. We might meet in the park or by phone, or somehow we exchange this key. Okay? So, and then what I'll do here, I'll take the message I want to send you. Yes? And I'll take a secret key that we agreed upon. And what I'm doing here, the first thing I will hash this one. And then the produced hash, what do I do with the produced hash? I encrypt it. And this will produce an encrypted message digest or a message authentication code. We call it message authentication code. Message authentication code, it means nothing but hash that is encrypted. What do I do with this hash? I send you the message plus the hash, this hash. Then when you receive the message, what you should do? Do exactly the same thing. run the exact same function. If the hash you will produce is equal to this hash, then the message was not changed along the way. Integrity is assured. I think before this can take place in a meaningful way, we both of us has to agree on a shared key. Yeah? Then here is a message I want to send you. What I do with this message, I pass it along the key to a hash function. In this case, which one did we just use? HMAC SHA-256. So what that HMAC SHA-256 did, it hashed the message, took the hash and encrypted the hash within the key. That will produce what is known as a MAC, which is a message authentication code. What do we do with this message authentication code? We send it along the message. Here is the attacker. They are intercepting exchanged messages. They can see the message, but they cannot change it. If they change it, this guy will detect the change. They will know that the message has tampered with. Because when the recipient will receive the message, what they will do? Take the message, take the key, use the same hash function on both sides, and then it will output a hash. If both of them match, then the message did not change. If there's no match, of course, this guy has changed the message. The attacker has changed the message. Now, why the attacker is not able to change the message? It does not have the key to generate a MAC. So if they change the message, they tampered another term using in security tampering, message tampering, it will be detected. Yeah. So if you store your passwords in plain text, what will happen? You are vulnerable to dictionary attack. How to prevent this dictionary attacks? By hashing and salting your passwords. Hashing alone will not help you. Yeah, hashing alone, because you need to also salt your password. What I mean by salting the password? A salt is nothing but a random number. So what you do, you take the password, before you store it in your database, take your password, take a random number, concatenate the two, and then hash. This way, you are protected against dictionary attack. The add user. So before I store the password as plain text, I use this library here, bcrypt hash, and I give it the password and I give it this salt around. And then basically it will, internally, at the end of the day, conceptually what it will do, it will take your password with some random numbers and then concatenate the two and hash it. And this will produce something like this. So your password will look something like this. Instead of being secret, it will be something like this. Okay? Now, when the user comes back, of course, when the user comes back, they will log in using, let's say, in our scenario I just showed you, they will send the password in plain text. Of course, in here you might use HTTPS, so you don't allow people to see your password in plain text. And when it arrives on the server side, as I explained shortly, what you do is you look up the username using the name, and then you use the same library that you used for encrypting, for hashing and salting your password, and you say, please go ahead, compare the password the user is giving me with the password that is stored on the database. Okay, and this bcrypt, it will use the same algorithm to basically hash and salt that password and compare the two. If they match, the user will be allowed to log in, otherwise login will be denied. Understanding, yeah, there is no magic. In this password, it has some pieces, maybe this first part gives an indicator to bcrypt what was the parameters used for hashing and salting. And the bcrypt uses those parameters. Yes, the bcrypt uses those parameters. Yes, to basically, most likely, hash this password that the user provides with the same algorithm and the same parameters as this one. Yeah? But remember, please remember this. This is very, very important to recall. You know, this hash function, it's supposed to be one-way function. There is no way, you know, once you hash something, there is no way you can reproduce the original text from the hash. That's the idea of hashing. A good hashing algorithm is the one that is really ensures a one-way function. Once you hash, you cannot reproduce the plain text. So you see here, encryption and decryption is very, very different than hashing. Hashing, in encryption, when you take a message, you encrypt it using some key, it produces a ciphertext, an encrypted text. From the encrypted text, you can go back to the original text. But in hashing, it's different. Hashing, you take a big text. Let's say, imagine 1 gigabyte text, and you produce from it 256 characters. How in the world you can reproduce this 1 gigabyte from the 256? So it's a one-way. And in all cases, once you do either way, either this way or the way the bcrypt library does it, you cannot know the password anymore. Yeah. So how you will verify when people log in, they give you some password, you will hash it and salt it. You hash it and salt it and compare it with a known hash. That's all you can do. But you cannot reverse back the password.